This is question 6. We're told figure 1 shows a sketch of a curve with equation y equals 2 over x where x can't be equal to 0. The curve C has equation y is equal to 2 over x minus 5 where x can't be equal to 0, and the line L has equation y is equal to 4x plus 2. In part A, we're asked to sketch and clearly label the graphs of C and L on a single diagram. On your diagram, show clearly the coordinates of the points where C and L cross the coordinate axis. The question carries 5 marks. If we consider C, it's this graph here moved down by 5 units, or if you like, a vertical translation of 5 units in the negative y direction. If we wanted to write that as a vector, we could write that now as 0, minus 5. All I'm going to do here is draw this curve, and then we're going to translate the curve. So if we get some coordinate axis, the graph will look something like so. So this graph first, and then we will do the transformation. So we come round and down like so. To the left of the y-axis, we will come round and down like so. Remember, this is just a sketch. It doesn't have to be massively accurate, it's just a sketch. So all I'm going to do is pick this up and move that down by 5 units and do exactly the same here. Before, the x-axis, or the line y equals 0, was the horizontal asymptote. So all I'm going to do is redraw this like so. I'm just going to make a quick alteration just to make sure now that doesn't cross, and we have something that looks like so. We could make this slightly neater here, I suppose. Let's just do that. But it's the general shape that we're looking for. So here we are, we come down, and that looks something like that. So we can say now that this horizontal asymptote is y is equal to minus 5. It's been moved down by 5 units. The vertical asymptote stays as the y-axis, or the line x is equal to 0. So this now is y, and I'll write it just here. We've got y is equal to 2 over x minus 5. We want to now state the point of intersection with the x-axis, which is just here, and that's when y is equal to 0. So if we just consider now, here is our equation, and we can put 0 is equal to 2 over x minus 5. Adding 5 to both sides, 5 is equal to 2 over x. Multiplying both sides by x and dividing by 5, x will be 2 over 5. So we can state now that the point of intersection will be just here, and this point is going to be 2 over 5, and then we're going to have comma 0. So that's the point of intersection. There'll be no other points of intersection with the coordinate axis. So that's the first one done. We now need to draw L. L is just a straight line. It's 4x plus 2. So what we're going to have then is a gradient of 4 and a y-intercept of 2. So if we go ahead and do that, we can place that on, and it will look something like so. So we'll come across, and it will do, give or take, something like this. So that is a rough sketch. We can label this up. Y is equal to 4x plus 2. This point right here is going to be 0, 2. That's when x is equal to 0. We now need to consider when y is equal to 0. That will give us the point of intersection now with the x-axis. So if we just consider when y is equal to 0, 0 will be equal to 4x plus 2. Subtracting 2 from both sides, minus 2 is equal to 4x. Dividing both sides by 4, we've got minus 1/2 is equal to x. So we'll have the point now on the x-axis. This will be minus 1/2, and then we'll have comma 0. So we've drawn our graphs, we've labelled them and shown the points of intersection. 5 marks in total for part A. In part B, we need to write down the equations of the asymptotes of the curve C. So I've already drawn now the horizontal one, so we can say that y is equal to minus 5. The vertical asymptote doesn't change, so we can say now that x is equal to 0. So we still have the y-axis, and if I wanted to put that on, I could show that like so. Of course, this is going to be hidden by the y-axis, but it looks something like that. So 2 marks for stating those two equations. In part C, we're asked to find the coordinates of the points of intersection of y is equal to 2 over x minus 5 and y equals 4x plus 2. We can see from the sketch that there are going to be 2 points of intersection. We'll have one just here and one just here. If y is equal to 2 over x minus 5 and y is equal to 4x plus 2, we can set those equal. We can say now that 2 over x minus 5 will be equal to 4x plus 2. So that's one way that we can solve these simultaneous equations. At this stage, I'm going to add 5 to both sides. So we have 2 over x is equal to 4x plus 7. I'm now going to multiply both sides of the equation by x. We'll have 2 is equal to 4x squared plus 7x. Subtracting 2 from both sides, 0 is equal to 4x squared plus 7x minus 2. We need to go ahead and factor this quadratic, and we can factor the quadratic to 4x minus 1 multiplied by x plus 2. So let's go ahead and write that in. We'll have 0, that will be equal to 4x minus 1 multiplied now by x plus 2. So let's just check 4x squared plus 8x minus x minus 2. So we can see from this now that x will be equal to 1/4 or x will be equal to minus 2. We're asked for the coordinates, so we need to now sub these in to go ahead and find the y coordinates. I'm going to use now the equation y is equal to 4x plus 2. So if we consider when x is equal to 1/4, we can say now when x is equal to 1/4, y will be equal to 4 lots of 1/4 plus the 2, which is going to give me that y is equal to 3. So we have the coordinates now 1/4, 3. So that corresponds now to our second point of intersection, which is just here. If we look at now when x is equal to minus 2, we can state now when x is equal to minus 2, y will be equal to 4 lots of minus 2 plus 2, and that will give us that y is equal to minus 6. So we'll have the coordinates minus 2, minus 6. And that corresponds to the first point of intersection, which is just here. So in total now we're offered 12 marks for that question, and we've used simultaneous equations and some basic graphing techniques.